Hello, everyone. Thanks for having me at MLconf. I have to say it feels like home here because sometimes you kind of deal in a vacuum developing a product that leverages statistical analysis, but here you get exposed to all kinds of problems that we actually see day to day, anywhere from like motivating our developers, finding the right data scientists, and putting the right leads, relevance of the data, how do you train the algorithms? So as a CTO, I have to deal with all of the above. So I'm glad to see that I'm not the only one, so I'm not crazy. So just a little bit about SIOS and who we are. Let's see. Sorry. Okay. So who is SIOS? We've been around since 1999. And we are headquartered in San Mateo, California, with offices in UK, US, and Japan. We are experts in application availability space. We have obviously quite a bit of customers and partners. Some of them are actually in the room, turns out to be. So how does that actually relate to machine learning, and how did we start? So personally, myself, I've started, I think right after the graduate school, I was looking for opportunity to actually see how I can practically apply what I've learned at school, like machine learning and statistical analysis, towards something that's actually people can use. So I started working for a company called Kaspersky Labs, and I was basically targeting the network, anomaly detection, network security, very interesting topic. Back in early 2000s. Then I switched to natural language processing, then signal processing, and human behavior analysis. And then I came back to the data center analytics with EMC. And I guess after 8 years break from a data center, I realized that things actually didn't get better; they get worse. It's kind of hard to actually now find ins and outs of what's happening in the data centers today. In the meantime, SIOS basically was doing application availability for the physical servers, and virtualization came in for virtual environments, and then cloud, of course, and they tapped into the cloud, and they trying to figure out what's going to be next, what's the next thing we can target, and basically that's where we met, and we realized, like, well, it's time to actually probably solve some of the problems that our customers deal with day to day, in terms of moving, their workloads from the physical environments to the virtualization environments, and trying to actually preserve the service levels and quality and stuff like that. Because I mean, as we talk about things like Hadoop and GPUs, I have to admit that IT is not simply ready for any of that, with the tools that they have available. So they need help. So that's why I think machine learning has an opportunity to tap into this. So I promise I can code more than just on the slides, but with this one, what I'm trying to say with this functional programming example, that we are not after the business intelligence, we are after IT intelligence. So this is kind of the core of what SIOS is working on. So how did IT started? And I'm not talking about the evolution from a kind of a monkey to the guy on a desktop, but really what seemed to be at the time this piece of hardware that was kind of screeching with the floppies in 30 so years just kind of grew into this mass of interconnected nodes, networks, different types of augmentations in terms of storage, and different types of layers, and of course complexities the application provide today to the data center didn't help as well. And so the question is, how come things like peaceful picture like this would cause the entire data center to blow up, right? So it's really, the answer to this, it's complicated. So if you look at the sort of progression as virtualization started emerging, I guess 15 years ago, which still hasn't actually sort of hit its core in the mission-critical applications, simply because people don't really understand how to deploy them. First it started with the data complexity being really low. The virtualization was at the beginning. People thought that, well, management tools are sufficient, simply because I mean, we don't have any critical apps. We're just going to do this in our labs and stuff like that, right? With virtualization kind of growing in its popularity, they realized, well, we somehow need to figure out where things go up and down, and we need to preserve the service levels for our customers. So let's target the monitoring tools. So that's another set that came into the picture. Then with the software-defined data center, where you have a bunch of APIs, a bunch of things are moving around dynamically, introduction of different types of hybrid clouds and things like that. Then, the solution was like, well, let's try to aggregate the data into one data set so we can basically index it and slice it in different ways. But that doesn't really help because it still requires human intervention, and IT simply doesn't have time to actually sit there and be data scientists and slice the data. They really need the answers. They need to really focus on the value and focus on onboarding new customers, deploying new application versus putting down fires, what they do typically today. A lot of our customers that we deal with who look at SIOS IQ, for example, our product as a solution, have 6,000 VMs, 40,000 VMs, and how do you find even simple things like idle resources? It's not really clear, right? Some of the cloud providers that we're dealing with, they have multiple tiers of support, but 86% of them actually of the problems actually drop down all the way to their core engineering teams who actually have to debug stuff. So it's clearly if we can solve the problem by providing some intelligence to the higher tiers of support, that would be a significant improvement. Because after all, once the applications are dropped into the infrastructure, it becomes the IT problem, right? And as I mentioned, when things like Hadoop start emerging and the workloads start changing, it's no longer a single server that puts the pressure on the shared resources in the virtualization, right? It suddenly became a workload that, as you know, can be very dynamic, and they work sort of together in a clustered systems, and there is no way to actually wrap your head around all of that with the set of tools that we have available today. And of course, the whole stack wars that start happening, right? You have VMware who push their products of virtualization. You have Microsoft with Hyper-V. You have open source solutions like OpenStack who actually create sort of like this layer on top of everything else. You have the cloud solutions like Amazon and stuff like that. You have emerging Dockers that can run as an alternative to VMware, or they can even create a sort of a meta virtualization on top of your virtualization, right? And that's where you can run your application. So it's a lot of permutations of all that stuff happening. So how do you actually figure out where are the problems when they emerge? And some simple things, just as is it a storage, is it a network, is it my virtualization layer, is it application is the problem? It's what IT is struggling with today. And the tools also, as you can tell, I mean, there's all kinds of open source solutions, proprietary solutions in different like monitoring, analytics space. At times they have like 20 tools deployed in large infrastructures to try to figure out ins and outs, and they still sit in the war rooms when the things happen, trying to figure out who to blame, which layer of the network or infrastructure. As I was started looking at this is the data from my past 4 years, as I was tracking Google alerts for on the topics of big data and IT and machine learning and IT, you can see that sort of the blue lines here represent the big data conversations that are happening and topics that emerge that Google was able to track, and the red is the machine learning. And as you can see by the regression, it seems like people figure out in IT space on how to deal with big data, meaning how do you store it, how do you index it. There are tools to do this. So now, how do you make sense out of it, right? And even though I'm not an analyst, I mean, I guess from my perspective, it's there is no marketing involved. I think it's pretty much just raw data to do. So after all, I think we're okay now, at least in IT space, of figuring out how to store the information, where to store it, how to index it, but how do you actually make sense out of it so it actually can be useful and on time. That's another aspect of it. Approximately, I guess, 6 months into us starting to develop a product in this space, The big guys like Gartner, I'm sure you've heard about before, but they're basically analysts in IT space who track different types of areas in emerging technologies and stuff like that. They came out with this new space called IT Operation Analytics. So clearly, we were right on time with this type of solution, seeing the problem, and our customers were seeing this problem. So, and obviously, guys like Gartner, who we talk to periodically, they also seem to be convinced that this type of solutions are needed. And that's when we started working on the platform for our product, SIOS IQ, called Semantic IO. The key requirements that I have established for us to make sure that we hit on as we develop this product is, number one, is presentation. Because after all, it has to be comprehensive for IT to actually understand. Today, there's a bunch of tools, like I said, there could be up to 20 tools that's being deployed in a data center that provide some kind of raw metrics. But it is really hard to figure out is it bad? Is it good? Who trends it? There is, in many cases, even though the tools are deployed, IT doesn't even use those tools. They use pretty much spreadsheets, they run scripts and stuff like that. And it's 2015 when people are, talking about GPUs and stuff, right? So they need something that actually can understand. It has to be comprehensive. From our perspective, the scalability and performance is the key. It's not something that we're working on. Is not a cloud solution because simply IT is very conservative into being able to deploy their data in the cloud and the trust and all this stuff. So they were looking for a solution that can be deployed on premise, but be scalable, almost like a SaaS type solution. So in our case, what's critical for us is to scale and perform well. And it's obviously kind of tricky, so the algorithms and overall data analysis and aggregation and normalization has to be tuned almost like telecom switches where we can perform really well. Every call that we have with our customers today ends up in the data domain somewhere, meaning they're asking questions: what kind of data you collecting? What kind of how can we retrieve this data? Data privacy is critical. So the requirement is to be transparent about the data that we have. Adaptability and portability is sort of the key differentiator of our product, I believe, because as you develop products in this space, it's critical to be able to develop something that can be easily switched without significant impact to your coding efforts. Meaning that, if we determine to use, let's say, medlib as a library to do some clustering, for example, we should be able to do that without, we should be able to switch the algorithm, perhaps even develop our own without significant impact to the layers underneath or above, rather, or the API. And, of course, the algorithm and data normalization and applying the expertise in this space are critical as well. What we do is we analyze, predict, and recommend after we collect and aggregate the data set. About the platform a little bit more, all those components that you see are sort of like completely decoupled. We have a V-graph, so we use a graph technique to be able to basically model all the information, the relationships, and even derive the relationships. There are some are not visible because, as you may know, in infrastructures where, IT deploys, things can relate without them specifically knowing about each other. Like, for example, there could be backup that's being run by, against multiple machines, but then simply with a scale of 6,000 or 10,000 virtual machines, it's simply hard to track, right? The analytics engine is truly pluggable. As I mentioned, it's critical for us to be able to run the algorithm and ensemble, and it's also be able to switch the algorithm. So it's basically, it plugs in depending on the use case that we're tackling. Like, for example, for anomaly detection, it could be one thing. For idle resources, using some regression algorithms, it could be a different item, but it all has to be very dynamically applicable to the framework. And we have at the bottom, we have a provider framework, which basically provides different types of data sets that could be coming from any type of information that we have from an infrastructure, whether it's VMware, OpenStack, Amazon interfaces, or even the monitoring tools or application monitoring tools. It's because our value is really about analyzing the data, not collecting that.
So let me just take one example, and it's I mean there are many of them. I have to say there are some are more trivial from the analytical perspective, are things like identifying idle resources. This one is quite complicated, and it's basically a day-to-day pain for IT. Is like trying to figure out what is the root cause of the problem, right? And we are implementing a semi-supervised learning way of trying to tackle that. So here's a use case which is happening quite frequently. Let's say you have number of hosts, and they store number of virtual machines. You know, I don't know if many of you know or not, but basically they're pretty dynamic these days. There are some, you know, sort of like algorithms in place by virtualization vendors that move VM virtual machines around. Sometimes they make assumptions that all the hardware is the same, but independent of that, the machines are constantly traveling, right? So how do you prevent situations where, like, for example, in this case, a virtual machine 4, as you can tell that relocated to a different host, suddenly started doing a backup of the machines that are on the host 2. So it suddenly puts a lot of pressure on completely unrelated set of virtual machines, right? and not only it impacts guys that are nearby, but also it impacts the network, it impacts the storage area network components, maybe not as aggressively, but still impacts it. So how do you actually find that out? Because today, basically, what's going to happen is the application users will make a call to the IT, and by that time, the backup can very well be done. So you have to basically do some kind of post-mortem analysis on the things using some monitoring tools or Excel spreadsheets, or trying to retrieve the information in some way, but the effects of that problem could be gone. So with the monitoring tools today, the result is you have a timeline, and this is basically directly from our customers that we're talking to. The monitoring tools will simply say, okay, well, this problem occurred, everything is green, I don't see anything, there is nothing down, it seems like no thresholds has been hit, really. So you basically, from the application, having a problem time to when the application user actually called in and said, I have a problem, to the time when the problem was actually resolved, if they were able to even catch that at the time, you're looking at 8+ hours. Sometimes it's actually 24 hours. Some problems, we've heard about, they take 7 days because, up to a week to figure out because they're more complex. But it always starts with a simple questions like, so is it an application? Is it the infrastructure? If it's infrastructure, which layer? You don't even have to go deep into the internal sort of components of the infrastructure like ports and LANs and switches and stuff like that. It's just, even at that level, it's hard to figure out what's happening. The application, the traditional analytics tools that are being deployed today, they are still threshold driven, so it's kind of hard to figure out. It still assumes that the IT, administrators actually know what's happening in that infrastructure, right? So the thresholds, when are they going to be hit, and whether they're going to be hit. So the time typically to figure out the problem is still roughly about 3+ hours, and there are multiple tools involved. So how do we approach that in our product? So first, we looked at the number of analytics algorithms, and we picked the clustering one, the k-means clustering, because it's, one thing is you can't really assume that IT will spend time trying to categorize stuff for you, right? So we are basically implementing the clustering, and we've hit some problems in terms of scaling the data, in terms of determining the k-means, so we had to kind of tune it in and make even our number of centroids dynamic based on the data sets and based on the use cases, but it seemed to be working very good for us. So it also provides us ability for our customers to point us to the data set that could become clusters, and we can start creating clusters around them, basically based on the input from the customer, whether they think it's not really important, whether it's not an anomaly. But essentially, you have over time period. And in this case, we're looking at the latencies. We collect the information, we train the algorithm, and then once the real-time data start coming in around the time, around the time frame where we actually do contain the data and it falls out of the clusters, we obviously mark them as anomalous. So next step, which is again kind of the component of the running this in an ensemble with is one algorithm being a result of one algorithm being input into the other. We perform the topological analysis or behavior analysis. So essentially, we correlate all the events in the infrastructure, trying to determine who is also involved in this problem. Or you know, whether it's anomalous right now or will become an anomalous in later, and also correlating that with different events of the infrastructure, like new virtual machines provision, failures on the hosts, migrations of the machines. So once we have the full picture, then we run our causality causal algorithm on top of that, which is naive-based algorithm. Here I have a sort of a graphical representation of that, where we have, with the red circles, I'm representing the different types of root causes, whether it could be a virtual machine being the root cause, or let's say, in this case, a data store, a storage being the root cause. And also on the sides, you have the observations, things like latencies, high IOPS or input output on the storage. And the way we approached that, we basically we bootstrapped it with a number of prior probabilities, and and that's what basically generates the results at the beginning as we learn. We also have a set of recommendations that are attached to the root causes that also come with priors. And then this is kind of an example of our user interface. What we do is basically, once we provide the input to the IT administrator in terms of what is the root cause in this particular situation, and they can obviously look at the symptoms, look at what's impacted into which point. They're also able to provide and rate sort of our results. And that's how we employ and based on that, we learn and adjust our probabilities from priors that we set up based on, sort of expert input. What are the likelihood of certain things, happening to what's actually happening in that particular environment. So what's next? I mean, there's definitely opportunities for taking it further. In terms of us being able to collect information from each individual deployment, and for deeper learning, to be able to figure out, how can we tune the algorithm, how can we improve the bootstrapping, the cold start with the training sets. Be amazed, but the best practices are kind of challenging today. It's not really clear what kind of hardware is best for what workloads, when should we cache the workloads and things like that, and what kind of hosts are better for certain workloads. So there's definitely opportunity to provide this type of recommendations to IT in a similar manner you would have, other business intelligence tools like, Amazon, for example, recommending to their customers which products to buy. So before I just want to mention that we actually have this tool available. A lot of people asking like, well, clearly the machine learning is a big hype. There is a lot of marketing around it. There is a lot of people talking about the, so there's a lot of people talking about like, how can I use it and where is it used elsewhere? So you can take it for a spin yourself if you have a infrastructure and download this tool and see what kind of results it provides to you. That's it. Thank you very much.